Hello and welcome to our video for Electronics 313. I'm Noah.
And I'm Miriam, and today we're going to be talking about threshold.
And threshold is important in digital electronics because the threshold is the division between a high and a low signal, which is going to be really important for all the things that we do. Here we have a diagram of how to wire a switch as an input. We have 5 volts on the top left coming in. We have a switch that can be turned on or off. When it's on, you can see below there's a 1 kilo ohm resistor going to ground, but the current will flow down through that LED in the center, which is protected by a 100 ohm resistor, so we don't get too much current through that. Then it will flow from the input there in pin 1 of our gate array and be inverted to the output, which comes out of pin 2, and that is hooked up to another LED protected by a 100 ohm resistor, which you can see on the bottom right of our screen. And both of those LEDs are connected to ground. There's a picture of our... Good. So what happens if we disconnect the input? Well, we would think that when we disconnect it and there's no current, it would go low and the inverter would make the output go high, which would leave the LED at the output on. Well, let's see what happens when we do it. The green LED is at the output, so we're going to turn that one on, and then we're going to disconnect the wire to the input, and we'll see what happens. As it turns out, the LED goes out, which means when we disconnect it, the input floats high and the output actually goes low because of the inverter.
This is a data sheet for the 7404 circuit. You want to note the pins and the gates on the circuit. Pin 14 is your 5 volts in to power the gate. Pin 7 will be your ground. You want to note 1 and 2 will be for your input and output, 1 being your input for your first inverter, 2 being your output for your first inverter. And you also want to make sure you know that anything you put into the system will be inverted to its opposite.
Alright, so here we've hooked up the oscilloscope with 2 triangle waves representing input and output. The solid triangle wave is our input. As you can see, it goes between high and low, and the broken triangle wave is our output. And if you look at that, the 2 points there are when it is high, the output is high, and that'll be when the input is low, and then on the bottom there, it'll be when the output is low and the input is high. And if you'll notice, there's a region in between where it's actually neither high nor low. And using XY mode on our oscilloscope, we can actually investigate that region where it's neither high nor low, which is called hysteresis. And if you observe on the next slide, we're going to have a bit of a close-up. You can see it's either high on the left or low on the right, but there's a middle region where it kind of droops off and it's not really sure whether it's high or low. So once again, that's the effect called hysteresis.
Here we're going to show you how to cascade a 7404 circuit, and you want to note on the bottom left hand corner is a red wire. That will be your input on pin 1. On pin 12 is a purple wire, which denotes your output. You also want to note that the color-coded wires, for example the green one going from pin 2 to pin 3, is the same value. It will be inverted and then goes to the output of pin 4 and to the input of pin 5, which is also inverted. And if you notice the other color-coded wires, they'll follow you through the same path. Here's a graph of our oscilloscope. Here you can see our time delay, the time that it takes for our output to catch up to the input value. And on the upper left-hand corner, you can see 34.2 nanoseconds is our time delay.